Okay, so in the last video we end up doing a little render and a bit of high-res version of our environment, and then we end up changing our resolution to 0.5, and now we have something decent, so we can continue with our next part, which is ocean, and then we'll get into the ocean foam. All right, so what are we gonna do now is, first of all, to begin with, we're gonna go into this oceans tab and then create a small ocean. And that's gonna create us some predefined network, and what we want is now to bring these guys here, just line them up a little bit better. Okay, and I'm just gonna hide this guy. So go inside. So if you guys remember, our grid size was 1000 by 1000. So I already have some values obviously set previously for to match the current wave spectrum of what I have in the video. So what we're gonna do is that I'm gonna mesh those. So I changed the grid size to 600. So it's not matching the grid pattern, but based on the angle, it creates a fairly unique shape. My wind direction is 180 degrees. My speed is 20. My directional bias is 5.395. Directional motion is 0.4143, and choppiness is 0.8. And then I believe I have some changes. Okay, so I have the loop over time is turned on as well. And then in amplitude, I have an amplitude of 5. And now my preview grid size is, by default, this is defined by the render grid, because in Houdini Oceans, the preview grid is not rendered, but the render grid is rendered with the baked out spectra of the ocean spectrum. So I'm just going to change my render grid size to 1000. Hello. Okay. 1000 by 1000. And I'm going to change my preview resolution settings to 1024 to 1024. So this is for if you want to I mean, these values are obviously going to be affected by your system settings, so it's quite debatable what you need or not. Okay, so that's pretty similar to what I have. Now you see these blocky shapes is because now we have more resolution than our spectrum resolution. So as I increase this, we should start losing those shapes. 12, resolution of 12 is equal to an 8K map. So what we're gonna do is probably, yeah, we can stick to that actually. But let's now get render grid in here, right under this guy, and let's get our spectra here, and we're gonna ditch this for now. Let's delete this. We'll bring it back after. Actually, let's keep it for now. I'm just gonna bring this back to 10 for speed's sake, and I'm just gonna I think it tries to calculate because this is, yeah, okay, let's just change the start frame. So this creates this default ocean foam. Oh, okay, because I did make a video recently about what I was trying to achieve, not video, Vimeo. What I was trying to achieve with this custom ocean wave. In this video that I uploaded, it's not that visible, but it's, we will see a much high-res result of it once we start building it up in our Houdini scene. Anyway, so so this guy on the left, let me just go full screen. This guy on the left is the default ocean spectrum foam. So I got some ideas from the Houdini 17 whitewater solver, and I kind of applied that to created basically a new popnet to do something similar on top of the ocean, and I think it worked kind of cool. So that's what we're gonna do as well. But let's get our basic shape first. So let's put these guys in the network. And then let's call this large, which is not large, but that's fine. This happens, I don't know why it gets stuck there. Large ocean spectrum. Okay, and I'm going to make this light blue. I'm going to circle this guy as well. Actually, because this and this is related to each other, I'm going to circle this both. Okay, let's put that right. Let's call this render. Render. Okay. Maybe let's make this guy blue. Okay. This is to be checked after. So now what happens is that the way this works is it has been quite improved, I think, from since 16.5 or 16. We used to write out the which is still supported in the Ocean preview export to texture. You can still write out the EXRs to move it to the other software, but here what the new Ocean shader does is, if I go to the Ocean shader, let's line these guys up. So it's now automatically linked to the path that we're gonna write out. So let's just write the spectra out to begin with. Where were we here? Ocean spectra, ocean surface, save spectra. Okay, so as I have mentioned before, this is not how I like the rename, so I'm just gonna copy one from here, right? So that's what we're doing. I just copy that path. Just gonna do the same thing again, but this time I'm gonna call it spectra. Maybe just call it, actually, yeah, spectra is fine. Spectra VGO SC, and let's write out the resolution of 8K for now, and that's will be probably more than enough for the rest of the tutorial. It's a 120 megabyte file. I can put that back now to 10. So now this is referenced. I'm just gonna put that back on auto. So now this is referenced on top of the spectrum geometry path here. And what this does is very interesting and it's very cool, is that it loads that file and it samples. It basically creates the deformation. It loads the deform value. It loads the spectra and then deforms it kind of deforms it during render time by evaluating the spectrum instead of reading the baked out EXR file or any other random file format, which is very cool because you don't need to bake a geometry, or you don't need to bake any EXRs on the fly. Every time you hit render, you have a high resolution render. So let's test that out. I guess for that to work, we need to, I can use our default guy here. Let's go, let's pin this. What I want, let's say I want cam 30. Okay, I would like to render what's visible, so this is for now fine. Let's turn this off for now. Ocean surface, ocean interior. Okay, let's hit render. Let's see what comes out. Cam 30. Let's turn this guy off, out. Let's go half res maybe for now. Let's hit render. So it's going to create our displaced geo. as we wait. Okay, cool. So we have our ocean spectrum. So this happens occasionally. What happens is, because our waves are so big, our displacement bounds are being hit. So to fix that, you need to go into your shader, and then I'm just gonna bump that up to 2, and that should fix that. And I think this is linked to here, so it should be fine. Yeah, okay. So if you see like these little gaps or something, that's most likely it's because of the displacement bounds and because your displacement values are too high. So now what we want is, this is purely artistic, but I will try to get similar colors. So as I have in my previous renders of this shot. So this is coming from ocean volume, because we are seeing, what we are seeing is what is refracted. So what we want is along, so my scattering phase is set to 2, my colors are set to 0, 0.17, 0.226. It's a bit more blue, and then now we need a geometry in order to tell the density, because we do want to see a little bit through the water, and that's our environment. So we just turn that on. Let's wait for it to come on the side as well. Loading slowly. Oh, I don't want two displacements. Let's do it again. Okay. Meanwhile, we can create another network here. Network box. Something like this big. And remember, it was blue. So let's make this blue. And let's call this step 2 ocean and ocean foam. Okay, so I want to see the water. I want to see these rocks through. Maybe it's a nudge visible, but it's definitely not enough. So the way to measure that is, what we can do is that there's like, we can turn on in the image, extra image planes, we can turn on I think it's combined lighting, and that should give us refraction. Let's wait for it. All refract, and as you guys can see, we're barely seeing anything. So what I'm gonna do is, that's because our density of our interior ocean is too thick. So let's go maybe 0.1, because I want it to be a little like tropical. And that almost made no difference. So I'm gonna go with the value I have in my other scene, which is fairly small number, to see if it's gonna make a difference. Okay, so now I think we are seeing some ground more, a little bit more, I guess. It's really not much. Oh, that's also, I think in ocean surface the default refraction is 0.5. Yeah, okay, let's go. I think in my ocean shader we need to match that as well. Ocean surface. My original refraction in my scene is 1 to 1. Okay, maybe it's the sun position, that's why we're not seeing, because it's backlit. It's here. Well, it's there. Let's change this, the light condition then. Let's bring that light in front. Okay, so that should give a direction like this. Okay, let's try that. Well, actually, in the presentation video that I have released, I don't have a distant light. I chose to have like a very overcast, bright but overcast day. Okay, let's see now. I just want to make sure that we are seeing through some of that detail. Moment of truth. Having strong resistance here, it's just not bleeding out, it's just too dense. But anyway, so we do have some, I guess when we turn the light we do feel it a bit more. It's a bit more tropical. Let's go like this just so we can see it a bit better. So let me bring this down. Let's dive it inside. Okay, so random everything. So what we're gonna do next is that we will start building our foam source to feed our simulation. In order to do that, I want to create a frustum from the camera to ditch anything that I don't need, because I need to create a velocity field. Like for example, in the flip simulations, there is actually what you see is the particles, but pretty much everything is vectored by the volume field, and there's a surface field as well in the flip simulations, and that's how the white water solver knows where to float the white water particles. And we will use the same technique to the similar work. So the way this works is, now what we can do is that we can bring in a volume. So that's why I don't want to generate a cache of this entire section with I don't want to generate a volume, velocity volume of the entire water area, but I want to focus on this section, because most of the time in the movies like this we work shot by shot, so we optimize everything. We don't generate a giant ocean that works under every camera angle, obviously. Okay, so in order to do that, let's create a volume, and we will bring in camera 30. So from camera, fetch camera 30. So because we are working based on camera 30 now, I'll call this guy density, give it a value of 1. Let's look from the viewport. Let's increase the Z far to 2000. Okay, so if I look from here, now you can see that this guy is 500. Okay, that's the frustum, that's how big the volume is going. And now what I want is to generate using this volume, I want to have a new water geometry that's actually deforming water geometry. So in order to do that, I'm going to get the can I use the same thing? I can, yes. So I'm going to put an attribute angle. I'm going to connect our preview grid to the first input. And then I'm going to connect the volume to the second input. And now I'm going to sample the volume. I think we can probably increase the resolution a little bit, division size 2, so it's not that dodgy. And so I can then type here, have a look into this volume that is coming from second input. So 1 is the second input, 0 is the order of the volume. So density, there's only one volume here, so it's the first one, and first one is always 0, so that's why this 0 represents that. I think you can also put here density, I think. Let's have a look. If you move over to the function, hit F1, and should load that function here. So yeah, you can do it with the volume name as well. I think there's an example. I'm not sure, but yes, so it's a string, so you can give it like density. So this initially, so if you don't know the order of, if somehow the order might change, this is what you can also use, but we only have one now, so that's fine. And then I say at position, and if it's less than 1, which means that if I think it's inside, if it's at the edge and outside, yeah, I think that's what it means. Remove point. It's ridiculous because I use these things all the time and I keep forgetting. That's like, was it bigger or smaller? PT none. Okay, so now what's gonna happen is, because this is a polygon soup, it didn't work because it doesn't have access to it, I think. Let's go, that should now sort that out. No? Okay, let's see what I'm doing wrong. So instead of deleting, let's give it a value. And let's observe that in our geometry spreadsheet to say at in equals 1. So everything is in, but everything shouldn't be in. It should be only within this section. It should be in. And it seems to be ignoring that. Volume sample. Okay, so this should be full geo, that's correct. Okay. No, actually, polygon should also work. That makes no sense. So what we can do then is we can, let's do this first. F at in equals volume sample 1, 0 at p, and this is going to return the actual values of that section. Okay, so those values are different. That's why somehow they're different. They should be different. Should have worked, but and then we can use a visualize SOP. Not need to be visualized. Visualize to. By the way, if it's a float by default, you don't need to put F. And then we can say visualize me in attribute. So this is a bug. Now the viewport is bugging out. Okay, now it's fine. So okay, so that's what is inside my frustrum. So therefore the value is 0.6. So I'm going to now, what I'm going to do is that I'm going to bring this guy back in. So now I know the value. What I'm going to do though is I'm going to create a channel here. I'm going to say threshold, double quote, close, And now if I press this button, a threshold will come here, and then this will allow me to use a slider to see what's inside, what's not inside. Okay, so if I look from here, as I pull this bigger, it's getting smaller. We get closer to the denser area, basically. Okay, and maybe I can then use, sure, alright. Okay, so what we can do is, though, I think we need to increase the window's size, so we have more padding on the edges. Do we need a bit more higher resolution? No, we're good, I guess. Go maybe 1000. Let's go a bit shorter, maybe in distance 500. We're squeezing the detail to a small area. That's too little. 200. Yeah, let's say that's fine. If I pull back, feels right. Okay. Oh, okay, sorry. I need, that's why this is weird. I think we need to change it by size to get a bit more accurate. Okay, now it makes sense. Okay, so now what happens is, if I look from here, so it's like a perfect cut, but the camera moves around, so we might see the edges. So in order to fix that, we have this window X, window Y. So I'm gonna go on X minus 0.1, and it should stretch out more on the left side now. Yeah, and then if I go, I'm gonna go here 1.1, stretched out there. Same here, in case camera goes up and down. 1.0. I'm gonna go less with this because this is in distance, and we're gonna distribute the points even less anyway. So now even if the camera was moving, which I think there is, now in this one maybe static, so it will be fine. So now we have an optimized area. So now what I can do is that I'm going to create another ocean preview node. Actually, I'm going to just create a reference copy of it, which is this guy. And now, which is going to the same spectrum. And now this guy is gonna go here. Okay. So now what I'm going to do is that I want, first of all, a downsample of 2, which is fine. And then what I want to do is that I want to create point velocity from this, because I might use them. And then, but I don't want to create point velocity here. So we can break that link and create it. And I want to deform it. Now, this part is the important part, because I do want to create a velocity from this information. So what we're gonna call, we're gonna drop in a null, sorry, and we're gonna call this, let's call it ocean foam area. And now in here, I want to break this link again. I want to create a velocity field. I want to break these links as well. And I want to break this link as well, because I don't want to affect any, I don't need to change anything up here. And this guy, I think that's enough for now. So I do want to create a velocity field, but I don't want to create a giant velocity field. So what happens is that they have a size, and by default, that has nothing to do with this. It's 10 meters by 10 meters by 10 meters, and it's a hidden velocity. What hidden velocity means that it's here, but you cannot visualize it. And the way to only visualize it, to use a primitive SOP, because you can define volumes to be visible or not visible to the viewport. And if you go to the volumes tab, adjust visualization, now it shows you that that is the default velocity, because you can set rainbow to visualize the values a bit better. I think that works that way, yeah. So now what we want is that this guy to be fixed to the bounding box of this. So no matter, so if we change the camera, if we move it somewhere else, it adapts automatically. So in order to do that, we're going to use a bounding box and centroid functions. And the way it goes is that you go b box because we need to get these values into here basically, and to call those you need the bbox and the centroid. So that's a double quote. Now we need to give address of what we want to fetch, which is ocean foam area, and then we close the double quote, comma, capital D. Actually it's here also, you can see the x size, the y size, or whichever information you want to get. So we're going to use the underscore x size. Now if I check, okay, so it's 332. If I check here, it's 332, which is correct. And then I want to copy this guy, and then I want to set here Z. Now I cannot really, well, I actually can, but then I have to call it from here. So I need to call it from deformation, which is a bit more complex. So we can get an actual true value, but for now I'm just going to call it maybe 50, which is fine. So it's errored out for some reason. Unable to embed the type. Did we do a typo? Yes, we did. Okay, so it's not the x size, it's the size. Okay, and now we need to center that because it's probably still not in the center. Okay, so I need to center that. So let's center that guy. So I'm just going to copy this whole thing. It's very similar. Change the bbox to centroid, and then remove this guy, and now it's going to give me the center x position of that. I do want to match the y position of the y because it goes up and down too much. Maybe I don't. So let's go here. Let's call it the Z. Okay, so paragraph 25. That's fine, I guess. And now let's go by size. I think this is by default way too low. Let's go 2 maybe. Okay, now we have a nice velocity field that we can use to advect our particles. So we are going to, I guess, so this is our geometry. We have a velocity field, nice. What we can do now is that we also want to create a surface field from this. There is a surface field node here, but somehow I'm not sure how this works. So I do prefer to create my own. I'm not entirely sure if this works just fine out of the box. So because if I set my volumes to and this define that I want to visualize surface, so it gives me the opposite. It's almost correct, but yeah, we can give that a try maybe next time, because we almost want to negate that. So if we do the opposite, maybe, why not? Okay, I'm just gonna turn it off now. I'm not gonna deviate so much from the tutorial. Oh, that's the bug. So this happens. This is really dodgy. So maybe this might fix it. Scene view again. Okay, hide outside. Maybe it's time we save. Oh yeah, because we didn't save. So we call this lesson 3 masters. We'll call this ocean surface. And when we maybe dive into the pop, we're gonna save it as a second file. All right, so now I'm gonna drop in a null. Call this null sim geo, or water surface is also probably fine. So I'm gonna blast those velocity fields. And then I'm going to use extrude volume with default values. And it's gonna give me this thickness, which I will use to create a surface field. I wonder if this was better to create without flat base. It's fine. Okay, and then I'm going to drop in a VDB from polygons. Default size is 1. It's a surface. And plug this guy here, and now this is how my Sim will be able to tell if I'm on the surface or not. So let's give it another null here. Let's call this in surface. Let's make this a black color. Let's come here. Let's call this now in well. All right. So now what we are lacking is the sources, which comes free with the ocean foam node. So we're gonna hijack some of side effects nodes, which is handy in this case. And the information to this guy comes from the spectra. So let's plug that in. Oh, we don't want it to simulate. We need to change the mode to emitter. And now that's the part with the size, is that we don't want a grid, we want it based on camera. It's almost like the same things that we did. We want to fetch camera 30. So I guess it will be safe then to copy this parameter to here. And these values are fine. So what I did for my final resolution, I did 100 and the minimum cusp by 17 and min velocity by 0.681, and I think I downsampled by 1. And so what I'm doing now is I'm displacing particles. So what does that do? So if you look from the camera view, so this is working based on, so you get like the camera distance, so like at the furthest part you get a lot less density. So I'm gonna go back to 100, and then what I want is that the shader usually evaluates so usually this is cached out to disk and everything is flat, as you can see, and in the render time these points are sampled and then put in the correct place in the side effects ocean shader, and then they get PC open sampled at render time to shade the water surface. But that's not what we're going to do. We're going to use this for actual simulation, so we're just going to displace this. So now this should sit comfortably on top of our surface. Okay, so now seeing that, I think we can make it a bit more noisy. So I guess that's too much. But all of this information is up to you guys, how you want, how much foam you want. It's all artistic based on references. You can continue. So now what we are gonna do is that we have this guy. We're gonna create some random attributes to use in our simulation. So let's create an attribute wrangle, or no, let's create a warp. Let's create an attribute warp. Point warp will do. Let's plug this guy in. So what is random in my source position? Every frame my position will create some random value, which is good. So I'm going to use a turbulent noise. I believe I plug this in inside, so I'm not going to skip these steps. So what did I say for my noise? I kept delegated noise, good, 0.25, 0.25, 0.25. Roughness 0.651. So I create a turbulence of 1, so it's generally very smooth. I put a fit. Value, and this has been bind exported as life. And that's a float, and it's a float, that's fine. But then I kind of fitted this from 3 frames to 6 frames. Seconds, sorry. And then I created another one. Turbo noise 2. It's 757. This is roughly the same thing. I did point to point for whatever reason. This is 5. And now I export this out as mass. Very important to create nice random attributes. All right, so I'm gonna create a random value now using the point number pdnum, okay, and then I'm going to drop in a multiply node, and I'm gonna right click on this node and say promote parameter so it goes outside the WOP that I can apply, and I'm gonna call this cell size, and in short it's gonna be C size. Okay, let's check how long has it been the recording. So that's 41 minutes. We can continue, and if you're not where we are at that 1 hour mark, we're gonna cut it and then continue with the next video. And then I exported this as cell size. And now if we go outside, we can visualize these attributes. So let's call this randomize. Okay, I think I can move this down. Here, come here. So we have 3 attributes. Let's see what they do. So I have life, just to create some random life values, and then I created mass, it should be more broken up, and then I created cell size. And we skip something. I think this is not 1D output. Yeah, it is 1D output actually. 1D integer in, integer out. So this is all zeroed out. It should be 0. Oh yes, because our default exported value is usually 0.0. So if you do 0.5, okay, so we get a lot of random values, very granular. All right. Let's delete that guy. Now I'm gonna create a rest position for each of my spawned points. So every particle that has been birthed into the foam simulation will know their original place, which is quite important. Okay, so I'll take these guys and let's call it custom fields for ocean foam. Let's circle this guy as well. Let's call it custom foam source, and let's create a null, and we'll call it in src as in source. Let's make this guy black as well. Okay, I think now we can save it. So now what we want also is, so this foam is coming only from the sea surface, but we have a giant geometry on the side here that is our environment. So we want to utilize that to create additional source, obviously. So in order to do that, we can create an object merge here, and let's bring in the rocks, and we can, so we want this guy, right? So what we want is to go to environments, and we can bring in our proxy geo into, oh, I didn't lock the object merge. Let's go here into this, lock this. Okay, so proxy geo, go up here, cool. Okay, so now we brought this guy here. Now what I want to do is that I want to scatter some points. what we can focus on, I'm just gonna change it a little bit here. What I want is, because I have a lot of points, I want to copy this guy, paste it here, and cut this geometry based on this. So to optimize things further, I just want to check how much my camera, if my camera 30 is moving. I don't remember, we don't have keys. Perfect. So now I can scatter even more points to get more defined density. Hurry up. Remove relaxed iterations. I don't find this very useful for our purpose. So maybe we can go 1,000,000. Okay. And now I'm going to create an attribute wrangle under this guy. And I'm going to say at C interaction equals 0, and I'm going to copy this guy, bring it in here, but this time I'm going to connect that to the deformed C surface, which is this guy, and then I'm going to put an attribute transfer. So this goes in the left, this goes there. And I'm putting it there because we're going to bring a bolt here after, but not now. So what I want to copy on these points is, I want to copy my velocity and my C in. And my distance, we will need to visualize, which is C int, right? C int. Ramped attribute, so I guess that's too much. Is this no? Okay, sorry, this needs to be set. Which one? One of them is, because the both of them are 0, so it's not gonna do anything. So let's change this guy to 1, and this is 0. Okay, and it's C int. Okay, so if we start, okay, there you go. So this is where the wave meets the rocks, and then I'm going to drop in another attribute wrangle, and then I'm going to type if at C interaction is equal to 0, then ditch all those points from myself, and it's gonna throw them away. Okay, so if we want to go much closer and more narrow, we still have a lot of room here. We can put 2,000,000, but there's by default a max points here, so I just turn that off. Again, all of these values are very dependent of your systems. Let's see what we're using now. Right now, this Houdini session is using, and we did some renders and everything. I'm gonna find it. Where are you, Houdini? Here it is. Right now, this Houdini session is has reserved 9 GB memory. Is it this one? Wait, is that not? Because I have another one. Yeah, that's the one. So right now, these are 9 GB of memory, which is fairly reasonable. Because we did some renders and stuff, so it's probably not even that much what we need. It's sometimes good to just save and open and close your Houdini. It helps. Okay, so I'm just gonna copy this null now, and then I'm gonna name this in rocks source, not rocks, rocks. Okay, so now our first step is ready. I'm gonna check 49 minutes, that's fine. All right, so now we are ready to create our dot network, but let's just save for now. I guess before any simulation, maybe we should bring in the boat, but I guess that will be another short episode. Well, no, that's fine. Okay, we can always go back and update. So let's just do what we were doing already. So in the next episode, the next video file, I'm gonna split it because the .NET of the particle simulation is quite complex, although it's also very, very interesting. So I think that's gonna take a while as well by itself. So I'm going to maybe, okay, let's make this a little bit more prettier. Let's give it another box here. Let's call it, because there's going to be an additional version here, so we can call this additional sources. Because also, before I simulate anything, what I want to do is that I want to walk you through, guys, with this my own file caching node, which I call file cache 2.0, which is not, but it's fine. So this guy, if you have seen on my channels, that it allows you to distribute your it allows you to run several tasks at the same time. It allows you to split 100 frame cache to be let's say split by a frame range. So if I'm caching one source file for any kind of simulation that is 100 frame longs, and then if I set this to 10, it's gonna, and if I set this parallel task limit to 10, it's gonna launch 10 Houdinis in the background, and it's gonna launch each one of them with rendering from frame 1 to 10, and then another Houdini will be doing 11 to 20, so and so forth. And in a lot of occasions, this speeds up caching quite a lot. And it also what we can also do is that we can let's say make a explosion simulation or a wind smoke simulation, and then we can, let's say, launch 5 simulations with different wind values at the same time, and then this tool will also make an MP4 file out of it, and I'll show you how this can be used. So this file itself is not entirely necessary to complete this tutorial, and the reason I'm saying that is because it's more Python related than Houdini related, but it's entirely showing how to use Python in Houdini, and with the wrapper called Hython, which is from SideFX. However, I am not going to explain how to install Python on your machines or how to download libraries, which I tried to use as small as possible, like extra libraries as small as possible. Most of the libraries I'm using are default libraries that you don't have to import additionally, but for Windows users, you need to know how to install Python to your Windows systems, but I will show some websites on how to do that, because you need to have the proper environment variables set for this to work out of the box. Other than that, it's very straightforward, but it's extremely useful, and it's, I think, one of the most exciting parts of this tutorial as well. Okay, so I'm gonna stop the video now before we move forward with the did we finish that part? Let me see, where is it? Okay, yeah. Okay, so in the next video we will set up the .NET for the whitewater, ocean whitewater, let's call it, and then, because for that specific purpose we don't really need, but we can speed up if we, yes. So I will show how to create the network of the whitewater ocean whitewater, let's call it. And then what we're gonna do is that instead we'll do some play blasting, but instead of caching it, after that video is finished, we will do the Python video, which could be probably up to 2 hours, I believe. And then we can go back and finally reuse this tool to maximize our output. All right, so thank you for watching this other episode, and we'll move on to the next video after this one.